So before going into some more involved problems, let's see one more function, right? This is mainly of an integer, correct? There's something called as fractional part as well. Okay, so let me use a new page. So it's called as fractional part. Okay, so it's usually denoted using flower brackets or parentheses, right? Uh, just 1 minute after I admit these people. Okay. So usually denoted by flower brackets. Okay. So something like this. It's written as a fractional part. It's read as fractional part of x and written something like this. Okay. So what is this? Let us take examples. Fractional part of 2.2. What is this equal to? Can anyone tell? What do you think it is equal to?
1 by 5.
2 by 10.
2 by 10, 1 by 5. Okay, 2 by 10 is same as okay, you want me to write it as 1 by 5. Okay, fine. So what about say 3.3? What is this now?
3 by 10.
3 by 10.
Okay, fine. What about say 9.98?
98 by 100.
98 by 100.
By
We need
50.
not write.
49 by 50.
Yeah, you are just simplifying the same, right? You're just simplifying this. So we need not always write it in fractions, right? Even though the name is fractional part, I get it why you are forced to write into fractions. But this is same as 0.2, correct? It doesn't matter, right?
Yeah.
Even this is say 0.3 and this is 0.98. Okay. So I'll give you one rule, right, to follow here, fractional part before giving another definition probably. So any number you take, any number which is x, correct? Any number you take is always the sum of fractional part plus integer part. Is it fine? It seems logical
Yes.
also, right? You add the integer part, you add the fractional part or the decimal part, right? When I combine those two, I'm getting the number back. Okay. So if I take, say, the same example, 2.2, just to confirm, the integer part is 2, correct? Fine. So the fractional part of 2.2 is 0.2. Fine. We can see the sum 2 plus 0.2 is 2.2, right? No doubts here. Is it okay? Yeah. So now let us talk about minus 1.2. What is the fractional part? What is the fractional part now?
Minus 1 by 5.
Minus 1 by 5 or minus 0.2 you mean? Okay. Can you use this definition and find out what it is? Can you use this definition?
Is it minus 0.8?
Minus 0.8. So we have got three different answers already. One answer is minus 0.2. One answer is 0.2. One is minus 0.8. So can we just use the definition and check?
It would
Which
be
is better?
minus 2 minus 0.8.
Yeah.
So it will be plus 0.8.
Plus 0.8. So what is your answer?
0.8.
0.8. 0.8. So all of these three answers are actually wrong. The correct answer is 0.8. Can we see how it comes? What is x? X is minus 1.2, correct? X is minus 1.2.
Yes, sir.
So integer part is minus 2. This we all agree. Not minus 1, minus 2. Because integer should be less than that number. We already seen this, right? From the definition. We can't have greater. So remaining part is the fractional part. Right? Remaining part is the fraction. So can you see what is the fractional part now? Take minus 2 to the other side, it will be 2. So 2 minus 1.2, which is 0.8. Is it fine? So let me take one more example. Say minus 2.3. What is this equal to?
0.7.
0.7.
0.7. Everybody agrees. Everybody agrees. If you have any doubt, you can ask me, right? You can ask me. The answer is correct, 0.7. Again, you can use the definition. Fine. Let's see some more. What about 10.8? 10.8?
0.8.
0.8.
So for positive numbers, it's direct, correct? Directly take the decimal part, right? Nothing to worry about, right? But for negative numbers, it's a little bit tricky. What we do is we go and
1
check.
minus the decimal.
1 minus decimal part works, right? That is just a simple way of writing the same. Or we can use the definition. 1 minus works. So 1 minus whatever decimal part you have will give you the answer. That is again from the definition only what you are getting, right? Why 1 minus? Because this number, when I get to the other side, you're subtracting that, right? So it will be positive and it will be greater than this negative number. Therefore, you're getting 1 minus. See, look at this example. It is 2 minus 1.2, right? So the remaining part is what I'm getting. So can anybody tell me what the range of fractional part is? What is the range? So domain, can anyone say? Domain?
Between 0 to 1.
Domain is 0 to 1.
Yeah.
Why should the domain be 0 to 1? We have seen examples outside 0 to 1, right now. We have seen a 2.2. There's no issue in taking those numbers, correct? Domain is a set of all real numbers.
Oh, okay.
Yeah.
That'll be all real numbers.
Yeah.
I thought only decimal part.
No. We take all the real numbers, right? See, domain is input again. So X can be anything. 1,000.1, fine. 10,000.1, fine. It's valid, right? As long as the equation is valid, we can take it as our domain. Okay. What about the range? What about the range?
0 to 1.
0
Yeah.
to 1. Or
Excluding 1.
minus 1 to 1. Some people are answering minus 1 to 1. So can it be minus 1? Or can it be negative? In any case, do you think can we get negative number? If you're saying, how many of you are saying no? Okay, we are not going to get negative number. How are you saying we cannot get a negative number? Okay. So can you give me a justification? Some people are saying no, right? We cannot get a negative number. Fine. Let me say it's right. It's correct. We are going to get only positive number. Or to be specific, the range is 0 to 1. 1 not included, obviously, because we'll never get an integer, right? That side, that 1 we'll never get. But 0 will get. 0 is also an integer, but we can get 0. For example, if my fractional part of 2 is asked, what is the fractional part? It's 0.
0.
Right? So integer part is 2 itself, but fractional part is 0. Any integer I take, the fractional part is 0. So I can get 0, but I can never get 1. Right? Okay. Now, why it can't be negative? Any justification?
Sir, we can get it from the given equation. X minus integer part of X will always be positive.
Yes. So can you see this?
It will be greater than or equal to 0 always, because X is always greater than or equal to integer part of X.
Correct. So we have already defined this integer part, correct? It doesn't matter. You could have defined fractional part, then found out justification for integer part. But now we have already learned integer part first, correct? So by this, we know that this is always less than equal to X, right? So at max, this can be equal to 0. Okay. So by the definition, we know that the maximum value can be 1. Sorry, minimum value can be 0. Correct? Because this negative, at most, it will go to X. But what about the other side? Why should it be 1? We know that, again, this is always greater than X minus 1. Right? So I've written it in a different way, so it will be confusing. So let me write it. So this is always less than equal to X and greater than X minus 1. Right? So if I simply use that also, you'll get an idea. It's always between 0 and 1. Right? Okay. So let me give one more example. Let me see how much you have understood. What about pi? What about this pi?
I didn't understand.
Yes, yes. It's not clear for you. Okay. What is not clear? Can you ask your exact doubt so that I can try to?
No, the less than 1.
Less than 1 and less than, why is it less than 1 and greater than 0?
Yeah.
Okay. See, this is x, correct? X minus, this is some variable. Okay. Some variable which is always less than equal to x. Is it okay? So will the minimum value be x minus x?
No.
No, think about it like this. This is x. This is at most x. If it is less than x, I'll get some positive number. Do you agree?
Yeah.
Any number less than x will give me a positive number, correct? So the least value possible is 0.
Yeah.
Yeah, that is at x. That you agree, right? So least value possible is when this is less than equal to x. So at equal to x, it will be 0. So that is the least value. Okay. Same logic on the other side. Now this number, whatever this number is saying it's greater than x minus 1. Is it fine?
Yeah.
So if I can increase it to whatever number I like, but to get the greatest value, if I take this as x minus 1, I'll get that. Do you agree?
Yeah.
If I take x minus 1, this is 1. So the greatest value is 1. Okay. Here it cannot be equal because here it's not equal. Okay. Similarly, here it's equal, therefore it can be equal to 0. Okay. This is by definition I am telling you. You can see the examples also and see. Whatever examples you have taken, right? You can see for negative numbers, I'm doing 1 minus that. Correct. To get the answer.
Yeah.
And for positive numbers, I'm directly writing the decimal part. So the number is always between 0 and 1. Obviously, I use the definition and got this. But if because you have seen examples, you can think about it using the examples. Is it okay now?
Yeah. Thank you, sir.
Okay. So my question was, can we find the decimal part? Sorry, let me use fractional part only, not the decimal part. Decimal part has a different meaning. So what is the fractional part of pi? Yes. Can you put your answers in the chat? The fractional part of pi. Okay. It will be irrational. Okay. Not sure. Okay. Only one of you have answered it right. Okay. Okay. Irrational. It might be irrational. Can we find a number? Can we find that number? 9. No, certainly not 9. Okay. Or it can be 1 by 7. Okay. Why 1 by 7, Karthik? Why 1 by 7?
If we take pi as 22 by 7, we'll get 22 by 7.
Pi is 22 by 7. Okay. Okay. Let me write down some of the answers given. So, if I take pi as 22 by 7, he's saying the fractional part will be, this is 21 by 7 is 3. So this
3
can
1
be
by 7.
3 plus 1 by 7. Correct. Correct. So you're saying that the fractional part is 1 by 7. Okay. And some of you are saying 0.14 because I think you have taken 3.14. Correct. So you're saying the fractional part is 0.14.
It'll be the same, no, sir.
It will be the same. Let me just check. What is 1 by 7 equal to? Is it 0.14?
Yes.
0.142857.
0.142857. This is for pi you're talking about, right? Saurav?
No, sir. About 1 by 7.
1 by 7, sir.
Okay, you're saying. So are these two numbers same? Are these two numbers same?
No, sir.
No, they're not same, right? So which is the correct answer? See, what does the definition say? Fractional part is what? We have seen this, right? We've seen this, correct? Fractional part is, let's say, fractional part is x minus integer part. Is it okay? So whenever in doubt, please go to the definition. If you're not sure what the value is, go back to the definition. So what is x? X is pi. You agree? X is pi. What is the integer part of pi?
3.
3. So is pi minus 3 a good answer?
Yeah.
Can you see pi minus 3 is taking care of that irrational part? You need not worry about calculating. You need not answer 1/7. You need not answer 0.14. You need not even go for more accuracy, right? All those answers will be wrong because there's a better way to write it, right? Suppose we are not able to write like this, probably we could have taken any one of those answers. But when there's a way to write it, you probably have to choose that. Is it clear now? Right?
Yes.
Yeah. So fractional part is pi minus 3. Any irrational number for that matter. If I take root 2, what is the answer? What is the answer now?
Root 2 minus 1.
Root 2 minus 1. X minus the integer part of that. That's all. Simple. Now, what about, say, fractional part of minus pi? Fractional part of minus pi.
1 minus pi minus 3.
Yes, yes.
1 minus pi minus 3.
1 minus pi minus 3. Can you write it in a better way?
4 minus pi.
Yeah, 4 minus pi, right? So we didn't add those two numbers. That's all. 4 minus pi. If you have a doubt, let's see. Let's use the definition. Here's the definition. So fractional part of this is x minus integer part of it. Integer part of minus pi is minus 4. Right? We're using the definition. So minus of minus 4 becomes plus 4, 4 minus pi. Is it clear? Right? So try this. Integer part of E, Euler's number. Sorry, not integer part, fractional part of E. Yes, fractional part of E. All we need to know, we need not know the value of E. All we need to know is E is a number between 2 and 3, correct? That's all we know. Enough. That information is enough. E minus 2. E minus 2 is the answer. Is that fine? What about fraction part of minus? Those have written E minus 3 is wrong. The answer is wrong. E minus 3 is wrong. You should get 3 minus E. Please use the definition properly. Look at this. X is minus E itself. X is minus E itself. Okay. And minus integer part of that. So minus integer part of minus 3. So that's how we are getting 3 minus 3. Fine. Okay. I'll give you one more example. You can try. Say pi square and minus pi square. What is this equal? You need not use calculators for this, right? You can do that rough calculations, right? Because we don't need the exact values here, right? We just need a rough estimate. That's all. So in a book, you can just try to scribble and get your answer. Okay. The only doubt you people might have is pi square, is it greater than 10 or less than 10? I think that might be the doubt, right? Just to approximate.
Less than 10.
Yes, less than 10, right? Less than 10. So if it's less than 10, then you'll have pi square minus.
Pi square minus 9.
Yes, yes. And the other side you'll have 10 minus pi
10
square.
minus
Pi.
You need not by heart all this. If I take a negative number, I'm going to get 10, 1 extra, minus all those things. Please use the definition. You need not use formulas or stuff like that, right? Just remembering the formulas and doing that. Instead, simply use the definition. This definition, obviously, you have to remember. There's no way we can do anything if you don't remember this. But that is more than enough for you to get your answer. So please, you need not remember you have to do 1 minus decimal whenever there is a negative number. All these things are not required, right? From the definition it will follow. Okay. So what is the next thing we'll do? We'll simply draw the graph. Right? We have drawn a lot of graphs by now. So one more. So we're trying to draw the graph of f of x equal to fractional part of x, or y equal to fractional part of x. Right? So try to draw. Show me in your cameras, right? What is the graph you're getting? Draw it. Take your time. Draw a rough sketch. Again, take sample values. See, drawing graph is very important. Why? Because some of the problems, if you use graphs, right, will be solved in like seconds. But if you go algebraically, it will take a lot of time. And maybe in 10th standard, you may not have so many problems related to graphs, but in 11th, surely you'll have a lot of problems. So if you are very comfortable with graphs, right, these graphs again you'll learn in 11th standard, so you will not worry too much about it. But if you're able to draw this fractional part and integer parts and all on your own, right, before looking at some textbook or something, that will really help you draw graphs. This is fractional part. Integer part, we already drew the graph yesterday, right? Sorry, not yesterday, but in the last class, right? So this is a fractional part of x. This might be a little difficult. You may not be able to get the exact graph, but some ideas are fine. If somebody could help me how to draw, probably we can figure out.
Sir, I have a rough idea, sir.
Yeah, tell me.
The origin point, should I show it to the camera, sir?
Yeah. But if you show it,
Sir, it's a rough sketch, that's all.
yeah.
Okay, sir.
Yeah, that sounds fine. Yeah, that looks fine. What about Karthik? Have you got it? I can't see anything from your camera.
I'll remove the background.
Okay, you can directly help me out. What should we do? Can you give me some sample values which we can try to plot? What are the values are we looking for? Any value is fine. Everything will help us plot the graph better. More the values, it is easier to solve, right? So easier to draw the graph. That's all. Can I start with
1.25.
First, we'll see 0 itself. What is the fractional part of 0?
0.
0. Okay, fine. What next? What next values? What do you want?
1.25.
1.25. Okay. What is 1.25 equal?
0.25.
0.25. Fine. Shall I plot these? Okay. Let me say this is 0 is 0 itself. At this is 1. If I take this at 0.25, say 1.25. So if this is 2, some 1/4 here, right? Somewhere here. This. So some more values we need. We plotted 2 points, 0 and 1.25. What other value you suggest? Anybody? Give me some more points.
2.3.
2.2. Okay. 2.2.
0.5.
0.5. Okay.
0.25.
Wait. 0.25. Somebody said, and somebody said 0.5. Okay. Let's see. 0.25 is giving me 0.25. 0.5 is also giving me 0.5. Then we can see when I went above, right, 1, I got 0.25. So do you get an idea, or at least between 0 and 1, how the graph is? See, at 0 it was 0, at 0.25 it is 0.25, at 0.5 it's 0.5 you're saying, at 0.75 it's 0.75, at any value between 0 and 1 it is itself, right?
Yeah.
Correct. So how will the graph look like between 0 and 1?
It will
X
go
and Y.
never-
Yeah. Yes, Saurabh.
A straight line.
It will go up but never reach 1.
It will go up but not reach 1. Okay.
Like-
So X and Y are same, right? It is something like this, correct?
Yes, sir.
Y equal to X, right?
Yes.
Y equal to X. So slope is 45 degrees if you want to do with slope. But at 1, it is not 1. At 1, what is the value? At
0.
1, 0. Okay, so this is my point. This point is in my graph, right? In my graph, this point 1 should be there. Okay, so because we know that fractional part of 1 is 0. Now we have seen 1.25. It is 0.25. Any other values between 1 and 2, we can see what will happen. Say 1.5. It's 0.5, correct? 1.5 is 0.5. So where is 1.5? Exactly in the middle, it's 0.5, somewhere here. What if 1.75? It will be 0.75. So 1 less, right? 1 less. But the graph, can you see it will be something like this only? Again, right? At 2, it won't be this point, it will be something here. It's 1 less. See, if it was same, it would have continued like this, correct? If it was y equal to x itself, it would be here. But now y is 1 less, right? So it is come down 1 unit, correct? It is this now. Now I think this is how we do graphs. We don't know how the graph look like. So we took some sample values. We figured out for one small part. The second part, I'm getting a better idea how the graph might look like. So let's be sure. Let's take some more values. Like at 2, it is 0 again, right? It's an integer, so it's 0. At 2.2, I think it's 0.2, correct? 2.5, it's 0.5. Again, you can see the pattern continues. It is 2 less than the number now, right? Or by definition only you can understand it is x minus the integer part of these numbers between 2 and 3. The integer part of numbers between 2 and 3 is 2, correct? So from that also you can realize it will be something like this again, correct? Again you'll have this not included and this included, right? Now I think for at least positive numbers we are sure that this will continue, correct? And this pattern will continue somewhat. So next, without even I think doing the calculation, you can guess it is something like this. And for next again, it will continue like this, right? It will repeat. This graph will repeat. What about the negative side? We just have to cross check for negative side because we remember negative side was behaving something different. When we are taking say minus say 1.2, you said the value is 0.8, correct? The value of the fractional part is 0.8. So not behaving exactly as the positive side. So let's check for some values, right? So up to -1, from 0 to -1, let us check. Give me some sample values. What should I check?
0.5, minus 0.5,
Minus 0.5. What is the value?
0.5,
0.5. At minus 0.5, it's 0.5. Okay. Some more.
Negative 0.25.
Negative 0.25. Okay. What is the value?
0.25.
0.75.
0.25?
Oh, sorry, 0.7.
0.75.
0.75. You can't make mistake. Now it's negative value, so be careful, right? Or use the definition. It is 1 minus 0.25. It's 0.75. For all the negative numbers, it's the same. So now let's see. 0.25 is somewhere here, right? 1/4. So at this value, you're saying it's 0.75, somewhere here. Correct. At 0.5, it's same 0.5. I mean, at minus 0.5, it's again 0.5. If you want, you can check for, say, minus 0.75. This will get 0.25, correct? Now, where is minus 0.75? Somewhere, 3/4, right? 3/4 the distance. So it is somewhere here. So can you see you're getting the same graph, right? You're getting the same graph. Obviously here at 0, it is actually equal to 0, not this. And here it is again -1, it is this. So again, if you continue the same logic at -2, again, you'll get the same graph, right? You'll get something like this. Here it's not included, here it's included. So we have seen our greatest integer function, the graph of something like steps, right? Here we have something like spikes here, right? So it's repeating. There also the logic was repeating, but obviously the graph was not repeating itself. There was an increment at least. Here the graph is exactly repeating after an interval of 1. Okay. Later on, probably in higher classes, when you learn about periodic function, this is one type of periodic function which repeats itself after an interval. Something like sin x and cos x, right? So it will repeat after a particular interval. Okay. So is this clear? Is fractional part and integer part clear? Any doubts here in these two? We're gonna see some more special functions in higher classes, right? I think for now, this is more than enough, right? 2 special functions. I think we have seen mod x, right? We have not gone in detail, but we have seen the definition because many of you heard about mod x before, at least, right? You know that it's the absolute value, but these two are totally new: integer part and fractional part. Okay, so many of you are saying it's clear. Then let's see some questions here. So if my integer part is equal to fractional part, what is the value of x?
It would be integer.
It will be an integer. Everybody agrees? Yes. Okay.
It'll be 0, sir.
It should be
Only
0.
zero.
Yes, not an integer. You take an integer and see. If it is 3, this side is 3, other side is 0. Certainly not equal. Okay. So just imagine how to solve this mathematically. How will you say that the only value satisfying this is 0? Now that's what I want to ask. This should be, see, I know it's 0. You know it's 0 by taking some examples, correct? Now mathematically somebody asks you, prove that the only solution is 0. What is your justification? Some justification you have to give. For Olympiads and all, when you write the proof, right, even though you know the answer, you have to write in a way, at least the person who is correcting the paper should know that you got the answer, correct? If majority would, by guessing right 0, probably you won't get that marks. So what is your justification? Why is it 0 and is there some other number where these two are equal? Or so, like for example 10, 100 or something like that. Is there a number where these two are equal? Do you think there is a number?
No, because the range of the fractional part will be 0 to 1.
Okay, yeah, that's enough. That's how you have to complete your argument, right? See, that is a proof. That's more than sufficient what you are telling. Okay, but you have to complete it that way. See, even if you feel that obviously I'll go for higher numbers, I'm not getting these two to be equal. That is not a justification. But something like this, the range of this is between 0 and 1. Correct. Range of this is between 0 and 1. So the integer part can be equal to only a number between 0 and 1, isn't it? Because that value what fractional part takes is between 0 and 1. Integer part can't be equal to anything else. And the only integer between 0 and 1 is 0. Correct. So the only case where these two are equal is at 0. Is it clear? This is one of the justification. You could have given it in any different way. way, you could have said these are all integers, correct? These are all integers. The only integer in this interval is 0. That's also a justification, right? There are different ways to write it, but some proof. Even if you think that it's not possible, you should. Why do you think so? And that you should be able to write in statement. That's all I'm saying. Okay. What about 0.5? Okay. Swasti, what is the integer part of 0.5? What is the integer part of 0.5?
0.
0, right? So 0 will be equal to, what is the fractional part of 0.5?
0.5.
So they are not equal, correct? They're not equal. Yeah. Okay. Yes. Any doubts here? Okay. Now, if I tell you fractional part of x is equal to 2, what is the solution of this equation?
It's not possible.
Not
Yeah.
possible. Yeah. So no solution, right? Whenever it's not possible, we say it's a null set, right? Or no value of x satisfies the equation. Okay. What if I say this x is equal to 0.2? What is the solution now?
All real numbers.
All real numbers. What about 10? Is it a solution?
No.
Obviously, all real numbers is not a solution, right? I'm asking the solution of this equation.
It will be 0.2 plus or minus x plus or minus n, where n
0.
is whole number.
Okay. Plus or minus. Okay. Or you can say plus or minus an integer, correct?
Yeah.
Right?
That's
Any
what.
integer. Plus or minus. Instead of saying plus or minus, you just add an integer, right? That's a good answer. Yes. Any integer plus 0.2. Right. People are thinking about whole number. Yeah, that is a one way of writing it, but it's not the complete solution. Correct. Whole number is only taking the positive part of the solution. Correct. There are negative solutions also. Like for example, even minus 0.8 is going to give you 0.2. Correct. If you write your solution as whole number, that's not considering these numbers. So integer is well and good, right? This is not 2. This is z or z, right? So any integer plus point, you're getting an idea, right? So how to write this solution? So for example, if the integer part was say 2, what is the solution? We already discussed this. So what is the solution?
2 to between 2 to 3.
Yes, x belongs to 2 to 3, where 2 is included and 3 is not included, right? But for fractional part, it is a little different. So because there are infinitely many values which is equal to 0.2. Okay. So graphically, if you want to solve this equation, see, graphically, if I am thinking of solving this equation, so this means what? Y is equal to 0.2, correct? I'm trying to solve for y. So where is 0.2? Just draw a line at 0.2. See, 0.2. This is 0.2. Just draw a horizontal line which crosses to 0.2. So wherever it intersects, all those are your solutions. Isn't it? Makes sense, correct? So similarly, in the previous graph, if you are trying to solve this, fractional part is equal to 2. I don't know if I have the graph here. Yeah, somewhere here. So fractional part is equal to 2 is this, right? So again, I'm drawing a line because y is 2, that's all. So which is part. So you can see that all this is a solution. Right? When obviously you can do this only when it's equal to some number, because when it's equal to some number means y is equal to 2. That's all I'm trying to solve. Right? One way to think about, right? If probably a graph is given and the equation is not given, right? So this is how you probably can solve. Right? So one difficult problem here, let's see if we can solve, is equal to twice fractional part of x. Integer part is equal to twice fractional part of x. Now, are there any solutions here? One is very trivial, right? Right? So 0, x equal to 0. Usually it always satisfies these simple problems, right? Directly when you have a fractional part one side and the integer part on the other side. If all are 0, obviously both sides will be equal. Apart from 0, is there any solution? That's what my question is. Okay, 2.5, 1.5, all different answers we are getting. Okay. Check. Point 0.5 plus z. Okay. Okay. Yes, Karthik. 0.5 plus z. Can you check for 10.5? Does it satisfy? Yes. Shushit is saying 3. Okay. 3. If you say x equal to 3, see, this side is 0, right? When x is 3. Sorry. This side is 3, correct? When x is 3. But the other side is 0. So certainly not equal. So 3 doesn't work. Okay. Okay, we'll check for 1.5. Somebody is saying 1.5. So what is the integer part of 1.5?
1.
So, right? What is fractional part of 1.5? Fractional part of 1.5.
0.5.
0.5, right? 2 into 0.5. So these two are equal. Correct. 1.5 is actually a solution. Okay. Somebody said 2.5. Let us check for 2.5 once. So 2.5 integer part is 2. Fractional part is again 0.5. So certainly not equal. 2 is not equal to 1, right? Okay. So 2.5 doesn't work. Any other solutions are there? Any method was there how you found out 1.5, or it was looking at the equation just trial and error? Or if anybody has a method, you can explain. It's trial and error, fine. I guess it's trial and error, right? Looking at the equation, probably it's easier to guess in this because it is 2 on the other side, right? Probably thinking in terms of 0.5 and multiples of 0.5. Okay. So I'll give you one more problem just to see if you can still guess the same values. 4 times integer part is equal to 3 times fractional part. Now can you guess some more solutions or what? The previous problem is not yet complete because we don't know if there are more solutions or not unless somebody explains that these are the only 2 solutions, right? For this problem again, 0 is a trivial solution, right? Both sides 0. Apart from that, are there any solutions? Try to solve. This is a little bit difficult, I'll agree, because you are not used to solving these kind of equations. So let's try though. Yes, Karthik.
The range of fractional part of x is from 0 to 1, right? So therefore the range range of 2 into the fractional part should be from 0 to maximum will be 2.
Okay, he's saying that this integer part is equal to 2 into the range of fractional part of x is a number between 0 and 1, right? The range is 0 and 1, 0 to 1, right? So 2 into that will be what? A number between 0 and 2, correct?
Yeah.
Okay, nice.
And and we know that LHS should be a whole, like an integer.
Yes. So what are the values possible?
It should be either 0.5 or 0. It should end with 0.5 or 0.
We'll talk about integer, but let's go step by step so that it will be much
Okay.
But what can the integer be equal to? Because we are talking about LHS, right? We said LHS is an integer now. So what can this integer be equal to? What are the possibilities?
It could be 0 and 1.
0 or 1, right? Only 2 possibilities.
Yeah.
It can't be 2 because 2 is not included at all. So only 2 possibilities, correct? So can we solve the equation using this information? Yes, we have this equation, correct? We have this equation. So we know that 2 into fractional part of x is equal to either 0 or 1. That's it. There are only 2 values. So you did not guess that 0.5 also. We know it's 0.5 because we know the final answer, right? But for a simple equation, it will work. But if I give you a difficult equation, probably you can't guess 0.5. Correct. So now you can see that we have solved it. We have not guessed that 0.5 value. See, this is either equal to 0. So this is equal to 0 only when x is equal to 0, or fractional part of x is equal to 0. Now integer part is 0 and fractional part is 0. So that means the sum is 0. That is one of the solutions. Fine. Next one, we are saying 2 into fractional part of x is equal to 1. The second solution. Correct. Second solution is x fractional part is 1 by 2. What was the integer part? Integer part is 1, right? We have taken it equal to 1, then we have solved it. So what is the second solution? 1 plus 0.5, which is 1.5. We've solved the equation. We have got only two solutions. One is 0, one is 1.5. Any doubts here? It's a little complicated here, right? A lot of logic involved, right? So if you have any doubts, please ask.
How it can be 1.5?
Yes. I couldn't hear you.
Understand that 1.5 solution.
This solution.
Yeah.
Okay. Have you understood that this part, integer part, should be either 0 or 1? Is that clear?
Yes.
See, this is 0 or 1 means this side is either 0 or 1, correct?
Yes, sir.
Yeah. So first I took this as 0. I equated and got my fractional part also to be 0. So my final solution is integer part was 0 and fractional part was 0. Fine.
Yes.
Next, what I do, second case. Second case is integer part is 1.
Yes, sir.
Is it okay? So now I got my fractional part to be 1 by 2. So integer part is equal to 1 I already took, correct?
Yes.
So what is the value of x? X is nothing but integer part plus fractional part. Therefore, it's 1.5.
Thank you, sir.
Yeah. A little more involved problem, but you can solve. If this is clear, you should be able to solve this problem. So try solving this problem. Solving it, not directly taking values and guessing. This time try to solve it. Yeah, by guessing, I think it will be very difficult anyways. That's why I gave a more difficult one than the previous one, right? So try solving the same logic. See, we have some of conditions on range, so we are trying to use the condition. You need not actually solve only using this. You can have even condition on this side and try to solve, right? Or there's another way also. You can convert this into x and fractional part and still solve, right? A lot of different ways. But let's continue with this. This sounds easier to understand. So let's try this. Okay, could anybody figure out the complete solution? No. Okay, let us go step by step. Let's see. Let's take this and let's try. Fine. Okay, what do we know? Yes, Siri, can you try this? Yeah. What do we know?
So the range of fractional part of x is 0, 1, 0 to 1.
Okay, the range, just 1 minute. Okay. The range of fractional part is between 0 and 1. Okay.
Yeah, so when we multiply by 3, it will be, the range will be from 0 to 3.
So the range is 0 to 3. Fine. What next?
So the integers in this range is 0, 1, and 2. So we can equate it.
4 into integer, correct? 4 into
Yes.
integer. Okay. So this can be equal to 0, 1, and 2. This is what you're saying.
Yes, sir.
So is there any integer? No.
It's only 0.
It's only 0. No
Yeah,
other value is possible.
Because greatest integer function of x cannot take 1 by 4 or 2 by 4.
This fractional part, right? So let us take cases. Let us take cases only. So this can be equal to either 0 or 1 or 2. So we're saying the integer part is 0 by 4. This makes sense. This can be equal to 0, no problem. But integer part is equal to 1 by 4. This is certainly not possible, right?
Yes.
Integer part is equal to 2 by 4 we are getting. And this is also not possible because integer part is always an integer, correct? So the only solution here we are getting is integer part of x is equal to 0, and obviously fractional part of x is also 0, right? How do I know that? Well, I simply substituted here. This is equal to 3 times fractional part. So fractional part must be 0. So the solution which I'm getting is x equal to 0. Okay. So you people had got solutions like 4 by 3 and 8 by 3, correct? Okay. Can you check this? 4 by 3 on the one side it is 1 times 4 by 3, right? On the other side it is equal to 3 times 1 by 3. So what mistake you have done is you have not considered this 4, I guess. Correct? So therefore you would have got that answer. I think that was a mistake. Therefore you would have got 1 equal to 1 or something like that. Sorry, it was integer part of 4 by 3, right? Which is 1, yeah. So 1 into 4 is outside. So it's 4 equal to 1. So those are wrong, right? Even 8 by 3 is the same issue you'll get. 8 by 3, if you take the integer part, it is 2, but there is 4 outside. So 4 into 2 is actually 8. On the other side, you have 3 into 2 by 3, which is again 2. So if there was no 4 here, your solutions would have been right. Okay, but with the 4 there, I think what you have done is you have not considered these cases, right? You have directly equated this to 1 and 2, right? Which is not correct. So this was one of the examples. See, the solution is only 0, but you people are probably putting in values and trying to figure out, right? Without solving, you're not sure if there is another value or not. See, for the previous problem, probably because you got some other value, you people were satisfied this might be the only solution. But in this case, right, so you are not never sure, right? How do you know whether there's any other solution or not? So here, when you solve this like this, when you solve this, you have taken into consideration all the possible values, right? Why? Because this can only give you this, and this is an integer, so only these are the possibilities. In these possibilities, only 0 is viable. Rest 2, because when I divide by 4 is not an integer. So the only solution is this. So is it fine? Now you're able to follow. So I'll give you a last example. So you can try this. 3 times integer part is equal to 5 times fractional part. So you can try and give me the final solutions. So if you people can get the answer, then probably we can move on to other problems. If you've got only 0, do you have a justification that no other value is possible? Yes, Karthik.
Yes, sir.
Okay, then show me what justification you have. So let's do that.
Okay. The range of the RHS will be from 0 to 5, right?
Yeah. So from same logic, this range is 0 to 1. Now because you're multiplying with 5, so the range becomes 0 to 5. Fine, agreed.
Therefore, the integer part of x, 3 times integer part of x can be equal to 1, 2, 3, and 4.
Okay, 0, 1, 2, 3, and 4.
Yeah,
That's
sorry,
all.
0 and 3, 1, 2, 3, and 4.
Yeah. Okay. So
Then if we take cases, we'll get x is equal to 0 and the integer part of x equals 0.
okay.
And 1 by 3, 1 by 2 by 3 also.
2 by 3. Okay.
And then we get 1, then 4 by 3.
Yeah, agreed.
1 by 3, 2 by 3, and 4 by 3 are clearly not the answer.
Yeah, because they are not integers, right? We are saying one side is integer,
Yeah.
other side some fraction, not possible. Okay.
and the integer part of x equals to 1 is not possible because range of in this fractional part of x is between 0 to 1 and 1 is not included.
Yeah, sorry, I didn't follow that part. So we are saying integer part is either 0 or 1. That we are agreeing.
Yeah.
What are you saying? Fractional part. Where is the fractional part in this equation?
No, like
In this original equation. This is what you mean. You didn't substitute it, correct? You substitute and check what are you getting first, right? See,
yeah.
two cases are what? Fractional part, integer part is equal to 0 or 1, correct? Two cases. So first case, 3 into 0 is equal to 5 into fractional part x. That means what? Fractional part of x is equal to 0, correct?
Yeah.
What about the second case? Did you check this? 3 into 1 is equal to 5 into fractional part of x. So isn't fractional part of x equal to 3 by 5? Isn't it a valid solution?
Okay, I become.
You directly equate it to 1. That we have to just substitute in the equation, right? Nobody said this is equal to the fractional part, right? Obviously, our equation is that, right? You have to use our equation and solve this. So what is the solution? Here, integer part was 0. So x is 0 plus 0, which is 0. Here, integer part is 1. So it's 1 plus 3 by 5. Or if you want to write in decimals, it's 0.6. So x is 1.6. If you want to write in fraction, it's 8 by 5. Right? I hope, I think some of you have already got the answer 1.6, right? It's clear for most of you.
So how did you narrow the range of integer of x to 0 and 1?
This part.
Yes, sir. At the last you said that the integer part of x will be 0 or 1, 0 between 0 and 1. I don't understand how you.
No. Did you get this part? These are the solutions which you're getting. Is this part clear?
No, sir. That entire part I am a bit
Okay.
confused.
Is this part at least clear? How we are getting 0 to 5?
Yes, I understand how you got 0 to 5.
Yeah. So the range of this is 0 to 1, right? If I multiply by 5, the range would be 0 to 5. Correct.
Yes, sir. That I got.
Now we are saying, look at the other side. What is this? What number can this be?
0 to
No, forget about this. In general, if it is 3 into what this is?
into the integer of x.
Integer, some integer, right? 3 into integers,
Yes.
correct? So it can take only integer values. Do you agree?
Yes.
3 into an integer will take you. So what are the integers between 0 and 5?
Okay, so 0, 1, 2, 3, 4.
Yeah, that's why I equated to 0, 1, 2, 3, 4. Is it fine?
Yes, sir.
Now what I did, I have to write 5 cases, so I just wrote it in the same line. That's all. Now I have to equate this to 0, correct?
Or then you dismissed each answer, sir, and then you got that. Okay, sir. I understand.
I dismissed these answers again by the same logic. I'm saying this side is an integer, other side is a fraction. That is not possible again, right? So the only possibilities is 0 or 1, because these are the only two integers. Right?
Yes, sir. Got it.
Then continue the solution. Okay. If you want to practice, you take any other value. You can take something like 3 times this equal to 10 or 20 times fractional part, and you just solve on your own. Whatever answer you get, if you have a doubt, right, final answers, you have a doubt, please substitute back in the original equation and cross check. That's all. See 1.6, if you want to cross check, see 3 times integer. 3 times integer part of 1.6 is 1. Other side is 5 times fraction part is 0.6. So 5 into 0.6 is 3. Other side is also 3. So yes, my solution is correct.
Okay, sir. Thank you, sir.
Yeah. And if you want to practice, always take some different. You can even take x, right? Instead of taking like this, you can take x equal to 4, say, integer part plus fractional part. Now you have 3 different equations. How will you solve this when you have 3 different types here? Any idea? We're not going to solve this completely, but can you give me the first step? What are we going to do? What would be the first step? because till now what we had seen is integer part equal to some fractional part, right? With some numbers multiplied. But now in this case, can you see that I have x equal to 4 times integer part plus fractional part? What can I do? No idea. You can always convert this equation. What will you convert this into? You know what is x, correct? What is x?
What if we bring the fractional part of x to the LHS?
Yeah, that's same as simply replacing x by integer part, correct? Integer
Yeah.
part plus fractional part, right? Now you can solve. You get the fractional part to one side. Oh, actually, fractional part gets cancelled. It will be very simple one, but you get the idea, right? So if you have x, integer part and fractional part in the same equation, you can always substitute x as integer part plus fractional part. Then you will have only two different functions you have to take care of, right? Otherwise, see, when you have three, solving is very difficult because here we're using some condition on this and saying that other side is integer. Now, if you have x and integer part and fractional part, x has no condition at all. X can take any number. So you won't have some rule which is bounded, correct? Here it was bounded because it's a fraction part. It's always a number between 0 and 1. The other side was bounded because it's always an integer. But x can be anything. Very difficult to work with this. So that's why what we do, we just convert x into fraction part plus integer part. We'll get the idea if that equation is good. So any equation, you can simply add x also and you can try to solve. It won't change anything. You'll just substitute this as integer part plus fraction part, then you'll try to solve. Okay. I think for functions, this is more than enough.